Indicate all that applies to the stratosphere. Stratosphere is going to be the second layer. We have the troposphere at the bottom. Stratosphere is the second layer. It's just below the mesosphere. And then the outer layer will be the thermosphere. We're looking at stratosphere. In the stratosphere, the word strato means layered. It's kind of like stratigraphy or a stratigraphic map in geology. And so with the stratosphere, it's very stable, layered, flat areas in the stratosphere. Convection occurs in this zone. Well, we primarily look at convection. Convection occurs where hot air rises and cold air sinks. That would be in the troposphere, where we have weather patterns where the hot air rises and cools, and then it rains and the cool air sinks back down. That's mainly a troposphere thing. That's not a stratosphere thing. It's obviously not the layer closest to space. That would be the thermosphere. Temperature decreases with altitude. We look up here at our temperature scale, and we can see it's actually going up as we go higher. Here's our temperature scale on the bottom. And as we go up in elevation, this red line is getting higher numbers on it. So it's going up. And the reason why that is because of this ozone that we have. Ozone is a selective absorber. It absorbs very specific wavelengths of light, and that wavelength, lucky for us, is ultraviolet radiation. The ozone, which is O3, O3 protects us from ultraviolet. That's supposed to be O, and that's a 3. It's the stuff that you smell if you go to the bumper cars at Busch Gardens, that electrical smell. That's ozone, and it is a high concentration of it up in the stratosphere. And so what happens is that solar radiation is coming down, it absorbs UV rays, and that's what actually heats up the stratosphere. And so at the very top, even though the maximum concentration is about midway here in the stratosphere, there is ozone near the top, and it gets first dibs at that incoming radiation. So it heats up much more strongly than the middle of the stratosphere does. So temperature does increase. It does not decrease. So we're not going to check that box. Of course, it contains the ozone layer. The ionosphere is this layer up here where we have ions. An ion is a charged particle, and this would be where solar radiation is bombarding the upper atmosphere, and we get the auroras that glow from those electrical charges charging the atmosphere. So that would be no. It is the second layer from the Earth, of course. Temperature increases with altitude. Well, yeah, we just saw that. Temperature goes up in the stratosphere, mainly because of that ozone that's absorbing those UV rays and protecting us in the surface from the UV rays. And then pressure decreases with altitude. Well, as we go up in the atmosphere, pressure is always going down in every one of these layers. As you go higher, the air just gets thinner as you get closer and closer to outer space. It gets harder and harder to breathe, and so those molecules, as there becomes less and less of them, there's less atmospheric pressure until you get up into the thermosphere and the exosphere, where it's basically non-existent. The particles, there's very, very few of them, and the pressure is almost zero up there.